Today's lesson will be dealing with absolute value inequalities. The objective is how do we solve absolute value equations and inequalities. We've already done absolute value equation previously in the previous unit, previous lessons, but it is going to be like a refresher course, so that way you know what the rules are before we do the inequalities. All right, so let's start. So again, this is a review of absolute value equations. So with absolute value equations, it shows a distance, a given number that is from 0. So if, for example, if you have absolute value of x equals 5, then x is 5 units from 0, as you can see from the number line. But it says, but which direction? It's both, because that means you're coming from the left and you're coming from the right. So that means x can be 5 and negative 5. So the absolute value, any negative number in absolute value will come out positive, and if you already have a positive number inside the absolute value symbol, it's going to be positive. And we also did, oops, let's do that again. We also did examples where we had to solve absolute value equations. And remember, every time you have an absolute value equation, there are 2 answers, because there are 2 cases to consider. The value inside the absolute value symbol is positive, so it's from the right side of 0, and the value inside the absolute value symbol is negative. That means it's coming from the left side of 0. So when we had to solve this problem, we know that there's going to be 2 answers for the variable. For this one, we had to split it into 2 equations. So this one was 6, and the other one, we keep whatever's inside the absolute value, take it out, and then we make this a negative, because that's the distance. And that's the distance that represents the direction from the middle number, which would be 9. So then when you solve it, so p, you add 9 on both sides, would be 15, and then p, you add 9 on both sides, will give you 3. So that means if you have your number line, you put your number in, they got 3 and 15. So these are the 2 numbers that will satisfy this absolute value equation. And even if you didn't do the number line, if you didn't solve it, you know that your middle number is 9, and you would be going 6 to the left, 6 to the right. So 6 to the left would be 3, and 6 to the right would give you 15. Same thing. And this is just another example. Remember when we had that formula, which was x minus m, x minus the middle number equals d, which is the distance. So notice that this is supposed to be a negative. You can turn it into v minus negative 4, because a negative times a negative gives you a positive, and then you got your distance of 2. So that means your middle number is negative 4, and then you're going 2 to the right and 2 to the left. So if you go 2 to the right, you get negative 2, and 2 to the left, you get negative 6. And if you were to solve this, so I'm going to use another color to show that if you didn't remember this, but you just straight solved it, you would have 2 equations. One of them, the distance would be positive, the other one would be negative. And then you would just solve, so this would be negative 2, and then this one would be negative 6. You got the same numbers. All right, so again, this was a recap of absolute value equation. And there's the formula that I talked about. X minus midpoint equals distance. So you identify the midpoint and then count the spaces to the 2 graph points based on that midpoint, and the distance will tell you how many units you go left or right. Okay, so keeping that in mind, we also did examples with graph where they show the 2 points in the graph, and then we had to write the equation. So we know that it's x minus m equals d, and I'm going to write that for both just to save the time. We got the 2 points. We have to find the middle. We can tell right away that 0 is going to be the middle. But if you didn't know, because let's say the numbers are spread apart very far, you could just do -2 plus 2 and average it out, divided by 2. So that will give you 0 divided by 2, and then it's 0. So 0 is your middle. So then you would have x minus 0, and your distance is 1, 2 from that middle point, which is 2. So that would be your equation. Or you could write it like x equals 2. And for this one, the middle, again, you can tell right away would be -2. So we have x minus -2, and the distance is 1, 2, so it's 2. And then you can simplify it to x plus 2 equals 2 as your equation for that absolute value graph. All right, like I said, this was the recap. You learned this already, but it's just a refresher, so that way it will lead you into doing absolute value inequalities. So with absolute value inequalities, let me expand this. If we got 2 cases, this is going to be the first case. If absolute value of x is less than, so I'm going to highlight that, is less than is less than 5, then the distance from 0 to x is less than 5 units. So you have your center, and therefore it says x is going to be greater than -5, and then x is going to be less than 5. So that means where your middle point is, you're going to have your numbers from -5 to 5. And you need those two inequalities, absolute value inequalities, to be true in order for it to work out. So your solution for this inequality in the set Euler notation would be x, and then it'd be -5 is less than x, but less than 5. So that means any x you choose has to be greater than -5, but less than 5. And it's not including 5 because there's no line underneath. This is just less than, and less than, yeah, for less than for both. All right. So we're going to do examples based on the and statement for the inequality. And here are the steps. So to solve an absolute value inequality, write the statement using the given inequality. Then write another statement using the opposite. Change the inequality sign and the positive distance to the negative distance. Graph the results, and then write all answers in set Euler notation. All right, this is going to be different from what you've done with the absolute value equations. So I'm going to show you what I mean by different. So you would write 2 different inequalities. So you have t plus 5, and then you would have less than 9. And then the other one, t plus 5, is greater than -9. This is where this is different from the absolute value equation. Get the highlighter. This information. So this is number 2. So notice how I turn this into a negative number, just like I did with the absolute value equation. One is positive, one is negative. But in this case, the sign, you change the number to a negative number, the sign is going to change. So you got to remember that. And of course, this is going to take a while for you to remember. I know mistakes will happen with this, but when it comes to absolute value, you know that you can have a negative number, and that negative number will have that sign that will change with it. So then you just straight solve the inequality. So then you would subtract 5 on both sides. This cancels out. And then you would have 4 for this one. And this one, subtract 5 on both sides. Cancel. and then you'll have negative 14. All right, so now I'm going to put my two numbers on the number line. So I have negative 14 over here, and then I have 4 over here. Now I'm going to pay attention to the directions that's happening. I'll use purple for this one. So okay, for t, t is less than 4. So that means any t I have has to be less than 4. And I notice that this is opened. This is going to be an open circle. So it's open, and it's going in this direction. Now I look at the t. It says t is greater than negative 14. So that means I'm going to be going, it's open, and I'm going to be going to the right. All right, so now I've got my graph. Now I can write the set Billet notation. So it will be t, and it says negative 14 is going to be less than t, but t is going to be less than 4. So that means any t that I choose has to be between negative 14 and 4 and not including those two. And there you go. So remember, with absolute value inequalities, you're going to have two inequality statements. One of them is going to be the regular, and the other one is going to have the number behind the inequality symbol be opposite, be negative whatever number, and the sign is going to change. All right, let's do another one. Actually, that was one of the examples. Sorry about that. We're going to do the one where it's an OR statement. So it says if absolute value of x is greater than 5, then the distance from 0 is x greater than 5 units. So you have 5 going in the left, negative 5 going towards the left, and then 5 going towards the right. So we already know about OR graphs where we have the lines going in separate directions. So they said that therefore x is less than negative 5 or x is greater than 5, giving us a true OR statement. So remember, it can be one or the other. So the solution set for this inequality in the set Billet notation is going to be x less than negative 5 or x greater than 5. All right, so we're going to do an example based on this. So we have the absolute value of x plus 4 is greater than or equal to 3, and we're going to solve for it. So again, you're going to have two inequality statements. So this one will be the original, and then the other one, the symbol is going to flip, and then you're going to negate the distance, negate 3. So again, you straight solve, and this will give you negative 1. And remember, whatever sign you started off with, make sure you bring it down. So if this was a greater than or equal to, have it end up as a greater than or equal to, not missing the line, because I've seen that happen too. And that's where mistakes happen. Then you bring that down, and then this will be negative 7. So then you're going to have negative 7 over here, negative 1 over here. I'm going to graph it. So notice that these are both closed. Closed circles. So I'm going to make the closed circles. And then the direction. This one says greater, so that means it's going to the right. And then this one says less than or equal to, it's going to the left. So then now for the 1, it's going to the right, so I'm going to go in that direction. And then for the 7, it's going to the left. It's going in that direction. And then once I have that, now I can write my compound. Back to the other lesson. My absolute value statement, inequality statement. So then that means x can be less than or equal to negative 7, or it can be greater than or equal to -1. And then this just shows you what I have, what I found, and how to write it. All right. So we're just going to do a few examples, so that way you get an idea. Okay, so just follow along. So again, it's good. There's going to be two answers. This is an absolute value inequality. So I'm going to have c minus 2 less than 6, and the other one will be c minus 2 greater than -6. And I'm just going to solve. So I'm adding 2 on both sides. I get c less than 8. And then the same thing, I'm adding 2 on both sides. And I'm going to get c greater than -4. Then I put my numbers on the number line. And then I'm going to figure out what direction, if the circle is going to open or close. This one is going to be open because there's no line underneath, so it's just open. This is also open. In the direction, since it's less than, it's going to the left. And then since this is greater than, it's going to the right. So now I'm going to have my open circles for both of the numbers. For this one, this is going to the left. And then from -4, -4, it's going to the right. So look at my overlap right here. So then my statement will be C, -4 is less than C, but less than -8. Oops, I messed up with that one. Let me remove this one. I just realized what I did. It's based on where my numbers are. So let's do that again. I gotta pay attention. So -8 would be here. -8 would be here. And -4 would be here, because that's closer to 0. Sorry about that. So again, let's do this again. So from 8. Oh, I was right the first time, but I just put negative. It's supposed to be +8. Oh my God. Let me do over. All right, so this should be -4. This is 8. So we have both open circles. And then, like I said, this one's going to, so 8 is going to the left and 4 is going to the right. So I was right the first time. I don't know what I was thinking. So let me write what I had to write. So it's -4 less than C, which is less than 8. All right. Okay, so that is the answer. All right, let's do another one. So we have 10 minus W and absolute value, and then we're going, and it's greater than 15. So we're going to do two inequality statements, one with the regular, and then the other one will have the symbol flipped, and then it'll be -15. We're going to subtract 10 on both sides. And this will be a 5. And then this is the -1. So we're dividing by -1. Remember what we do with the negative when we're dividing it? It's going to change the inequality symbol. So it's going to become a less than. And this would be -5. Then the next one, I'm going to subtract 10 on both sides. A -W, which is less than -25. This is our invisible one that we're going to divide. So that means the symbol is going to flip. And then we get a 25. And let me move this down further. Going to put my numbers. So this would be a -5, and then this would be a 25. This is going to be an open circle, so we'll this answer, and then this direction, since it's less than, it's going to the left, and this greater than, it's going to the right. So I'm going to start here, so I'm going to the left. and then this one's going to the right, and it's open circle. Let me put the open circle. And then the inequality statement, absolute value inequality statement will be, since it's W, so it will be W less than negative 5 or W greater than 25. Okay. So now this was a simple inequality, absolute value inequality. Now this will be a little bit, I shouldn't say complex, but another step added to it, where we have to isolate the absolute value expression. Remember when we did that with solving it with equal sign? It's the same steps, but we're using inequality. So for this one, we would have to, I'm going to rewrite it. We have to isolate this absolute value expression. So we need to subtract 9 on both sides. And then we will be left with negative 1, absolute value of negative 1 plus n, which is less than negative 4. Now we can split it up, and I'm going to use another color so that way it can be distinguished. So negative 1 plus n is less than negative 4. But there is something here. Notice that the number here, negative 4, we should have a positive. So when you, before you even do anything, notice that, let me make this. Notice that our distance is negative. If our distance is negative, we're not going to have a solution. But let's work it out and see what happens. Let's work it out and see what happens. So this one flips and this becomes a 4. Because we know that one of them has to be positive and the other one has to be negative. So let's see what happens just out of curiosity. So that cancels out, and this will be negative 3. And then this one will be positive, positive, and this will become 5. So if we put our negative 3 here, we put our 5 here, both of the circles are open. This one is less than, so it's going to the left. And this one is going to the right because it's greater than. Alright, so now if I were to plug in a number, so let's mean any number in here on this number line, I'm going to plug it back into that equation, inequality, and see what happens. So I'm going to choose 6 as my number for n and see what happens. And see if I come out with the correct statement. So this one will be 5 plus 9. So look what happened. It says that 14 is less than 5. Is that true? No, this is false. So this is where this does not match up to what's going on here, because the distance is negative. So remember it. If you end up doing something like this, or they give you a problem where there's a negative number as a distance, there's not going to be any solution. So the answer here is no solution. No solution. Because you cannot have a negative distance. You can't have that negative behind the inequality symbol, or if it's an equal sign symbol. So there's no solution. All right, let's do the other one. We have that 3 in front of that, so what we need to do is we have to divide it, because we need to isolate the inequality, the absolute value expression. So we divide by 3 on both sides. The 3 will cancel out, and we're left with this. And now we can split it in 2. This one will be k minus 2. It's less than negative 3. This will give us This will give us 5, and then k will be less than negative 1. So we have negative 1, we have 5. It's both going to be open circle, and in the direction of 5, it's greater than, it's going in this direction. And then for this one, it's less than, so it's going in that direction. So then our answer will be k, which is k greater than 5, or k less than negative 1. All right. So the next one, we're going to write an inequality, absolute value inequality statement. So we have this one as open. So it shows that I'm going to choose x for my variable. So it's x is less than 4. And then this one is x is greater than, do the right symbol, x is greater than 12. So it's going in different directions. This is going to be an or. So then I have x. So I have 4 is less than, x is less than 4, or x is greater than 12. And since they're, like I said, they're both open circles, so it have that symbol. Next one. I know this is going to be an and statement because it's overlapping. They're both closed, so negative 8 is closed. And then 8 is also closed. And notice that everything from negative 8 is going to the right. So that means x is going to be greater than negative 8. And everything in 8 that's going, is going towards the left. So that means anything x will be less than 8. So now if I have to write the statement, it will be negative 8 less than x, which is less than 8. So always remember, this is the format for and the other one, or, will have the word or in it. All right. There was a lot to digest with the absolute value inequality. So I'm just going to go back to where we started. So remember, with absolute value equations, you had to write 2 different equations and then solve for x. There's always going to be 2 values for x. But with absolute value inequalities, we have an and an or statement. So the and will have this format, as you can see. And then for the or, you'll have the word or in it. When it comes to the and statement, you'll have, when it comes to solving absolute value inequalities, you're going to have 2 inequalities. One of them will be the same as the original, and then the other one, the symbol will flip and the number behind it will be negative. Once you have that, you put it in the graph and then figure out what it looks like and then write the statement for it. With the or, the graph, the lines are going to go in separate directions. So again, you break it into 2. One of them will be negative with the symbol flipped, and you solve, figure out if it's open, close, and then which direction. But there are going to be cases where, like this, where you need to do multi-step. So you need to isolate the absolute value inequality, absolute values expression, whether you're going to add the number or subtract on the other side, or you're going to divide or multiply on both sides just to get the absolute value expression by itself. Once you do that, split it in 2, find the 2 numbers, the 2 inequalities, put it in the graph, and then see what's going on. So number 5 was a different example, a different type of case, where after we subtracted 9 both sides and isolated the absolute value expression, we noticed that the number behind the inequality symbol was negative. So what we learned from, especially with the absolute value equations, that your distance cannot be negative. If it's negative, look what happened. our statement becomes false and it does not match up to what we've done. So anytime you see a negative number after the inequality symbol, you know there's not going to be any solution. You don't even need to do any work. You just write your answer, no solution. All right, so this, and again, we also graphed, look for information, open, if it's open or closed, in which direction, and then it tells you if it's going to be an or an and. Or, separate direction, and it combines, it's overlapping. So again, if you have any questions, I know this is a lot and it can get confusing. Any questions and you want more clarity to it, more examples, please feel free to email me, ask me, and I will help you out. Okay, so we've come to the end of this lesson, and I'll see you around.